continue. So for these two equations, we take a limit. You end up with this equation right here. Right? So left hand side is the same, right hand side, you sum up, and it becomes the integral of x tilde dw. Right? So you integrate with respect to weight. Right? So the x coordinate. And same thing for the y coordinate. Okay? So there you have it. You simply just move w to the right hand side. So these two equations will be the equations to find the center of gravity of any rigid body. That's it. Okay? In a 2D surface. Okay? So x bar, y bar. Right? So the coordinate of center of gravity is equal to the integral of x tilde dw divided by the entire weight of the rigid body. Right? And same thing for the y coordinate. Right? Again, the tilde represents the location, right? The coordinate of the individual element, right? The individual tiny piece. Okay. So this is center of gravity. What about centroids? Are they the same? Well, they are the same. Right? Centroid and center of gravity are exactly the same point if this rigid body is made out of the same material and homogeneous material everywhere. Okay? Which means that this rigid body is made of the same material, just one single material, okay, of the same density everywhere, okay, on the rigid body. If that's the case, then the location of the center of gravity will be exactly the same as centroid. But let's prove it. Now we'll talk about density, right? Material has material properties, right? And density is probably the most important material properties. Density is a symbol of rho. Okay? So now rho is defined as mass divided by volume. Okay? How much mass a certain volume contains. Okay? So that's how density is defined. Now, a mass and weight are closely related. Right? So weight equals mass times center of the gravitational acceleration. Okay, so mg. Or mass equals weight divided by g. Alright, let's move this over. Okay, so now we have this, and we have this. Let's bring this in this equation. So density equals weight over g times volume. Okay. Let's move things around a little bit. So I can rewrite this as weight equals rho times move this over g times move this over g. Okay. So now we have this relationship, right? So weight is related to density and gravitational acceleration, which is a constant, which is 9.81 meters per second squared in SI units, and the volume. Okay, so now let's bring this equation into equation 1 for our center of gravity and see what it looks like. So into equation 1. So x bar equals this x tilde stays the same, but dw now, dw is rho times g times v. Okay. And then weight itself is rho times g times v. Okay. Keep going. Now, if rho is the same, is a constant. If rho equals constant, that is the key. If rho is constant, then we can take the rho out of this integral. Figure it out. G is a constant, you know that for a fact. So G can be taken out as well. So what's left is integral of x tilde dv. Okay. And then we have rho g v. Okay. Now look at that. Rho and rho cancel out. G and g cancel out. That's the beauty. We can cancel out only if rho is constant. Okay. That is, if the rigid body is homogeneous. Okay? Like one single material. Okay. Let's do something with this V right here, the volume. Volume of, well, this piece right here. Right? Remember that I have added a little tiny thickness, H. Okay? So, the volume of this guy right here is simply equals to the area, right? So the surface area of the surface times H. That's it. Okay? And same thing for each individual piece, right? The small element has the area, a tiny area, right? And the volume of this element is the tiny area times height. That's all. Okay? Same thing, height. Okay? So x bar now can be reduced to dv now becomes dA times h. Okay? And volume is A times h. Same thing here. H is constant. Okay, same thickness, tiny little thickness. So take h out. All we can do is cancel it out. So therefore, what you're left with is simply this. Okay. And you can do the same for y. Right? So y coordinate is exactly the same. Right? Therefore, let me write this closer to this a little bit. Right? So x bar equals x tilde dA divided by area, and y bar equals y tilde dA divided by A. That's it. Now, these two equations, right, we call equation 2, are the equations to determine the coordinates of centroid. Okay? And the other thing, the equivalent only if material is homogeneous. Okay. So you have the freedom, you have any set of equations, okay, equation 1 or equation 2, right? And you give you the exact same answer. Okay. And the good thing about this equation 2, okay, centroid, is that if you're working in terms of area, which is purely geometric quantity, instead of working with W, okay, which involve W here, and material properties, right? So, if the rigid body is homogeneous, then you can just use these two equations to find x bar, y bar, to determine the location of centroid or center of gravity. Exactly the same point. Okay? Alright, let's look at an example.